Next up, we have a session called Sustainable Computing in the Age of AI. I keep hearing something about AI. Maybe there's something to this coming up. So please do me a favor. There you go. You good? Cheers. Baggage carousel 2. There we go. So please join me in welcome Jeff Wittich from Ampere. He's the Chief Product Officer. Please welcome Jeff.
Thanks, everyone. It's always great being back here at CloudFest. And if you've been here for the last couple of years, you've heard Ampere talking about the products that we've built, the cloud-native processors, the CPUs that we've developed in an incredibly unique way to excel at cloud workloads of all types. And you've also heard us talk about the need for sustainability in the data center. So I'm here to tell you that there is a critical inflection point ahead of us when it comes to sustainable AI, especially sustainable AI in the cloud. And I'm here to say, get over GPUs. There's a better solution for the vast majority of AI workloads. In the market today, what we see many customers moving from is a phase where they are training their first models or retraining models, optimizing models, using a specific specialized set of infrastructure. And then when it becomes time to move from AI training to AI inferencing, they have a new problem on their hands. They've moved from a massive single problem to a gigantic scale-out problem. And so I'm here to talk to you about using the right tools for the job. Now, will a GPU work for AI inferencing? Absolutely. But it's akin to driving a Formula One race car to work. Will it get you there? Absolutely. But it'll consume a lot more fuel, it's incredibly expensive, and good luck getting one. And it's unlikely to get you there that much faster once you take into account traffic and real-life conditions. So, wrong tool for the job. Definitely has a place. I'm here to talk to you about using the right tool for the right job when it comes to AI inferencing. And you know, this is more critical than ever. Not only have we seen an explosion in AI compute demand, but if you saw the New York Times about a week ago, we're starting to see for the first time in over 15 years that energy consumption is on the rise. For instance, in the US, we had about 15 years of completely flat energy consumption. And over the last couple of years, energy consumption has begun to rise, thanks in part to electric vehicles, also the massive growth in data centers. Both two objectively good things, but we have a large part to play in ensuring that we are able to get back onto a flat energy consumption path. So what have we built at Ampere? Again, if you've been here for the last couple of years, you've heard us talk about our cloud-native processors, the vast array of workloads that we built these processors for, everything from web applications, databases, media encoding, and the same types of technologies that we included in these CPUs for those types of cloud workloads also excel at cloud workloads like artificial intelligence. And we've made it incredibly easy for you to use Ampere processors for AI thanks to our software libraries. We have a software library called AIO. This software library does a couple things for you. One, it ensures that all of the common frameworks that you might be using, Onyx, PyTorch, TensorFlow, making sure that those work seamlessly out of the box. It also has an optimization layer below it. Now, the good news is you don't need to do anything. The AIO library are automatically recognizing the underlying hardware and does a couple of things from a performance perspective. It ensures that the data is structured in such a way that it's a good match for the underlying hardware, making sure the data flows in and out of the processor very, very efficiently. It also optimizes for the specific instruction set in the specific microarchitecture of our CPUs. So the benefit to the end user is all of your popular frameworks run. You don't need to do anything to the model, and you'll get amazing out-of-the-box performance when using Ampere processors for artificial intelligence. And what types of artificial intelligence use cases are we talking about? everything from the more traditional analytical AI models like natural language processing, computer vision, recommender models, but also the incredibly popular large language models for applications like generative AI. Now, a lot of you are probably familiar with the way that the AI workflow typically runs, but let me talk in a little bit of detail about where Ampere has the best place. As you know, you typically start with AI training, possibly training a tens of billion parameter model, hundreds of billion parameter, maybe even trillion parameter model today. This is one enormous task that might take you weeks, even months to complete. Now, there's probably a specialized solution for this type of massive AI training, almost supercomputer type workload. And once you're done training the model, you validate the model, maybe some retraining occurs, some model optimization. Now it's time for inferencing. As I mentioned before, inferencing is the giant scale-out task. With AI training, you probably had a different set of optimization points. You were looking to reduce the time to train, and maybe you were willing to throw expensive and power-hungry hardware at that problem. When it comes time for inferencing, though, this is now a very typical cloud problem. Now we're talking about a gigantic scale-out problem. So now you're taking a model that maybe took weeks or months to train, and you're deploying that model across many, many machines all around the world. And when you look at the number of compute cycles that you end up consuming, it can actually be multiple times more compute cycles consumed on aggregate in the inferencing phase than in the training phase, because it's one smaller problem running millions, maybe even billions of times per minute. And that's where we have an amazing opportunity to build a more sustainable solution. If up to 85% of all the compute cycles are going to be devoted to AI inferencing versus AI training, we can obviously solve a bigger portion of the AI sustainability problem by tackling the AI inferencing efficiency problem right now. And if we look at what Ampere CPUs are capable of delivering, just looking at our 128-core Ampere Ultra family processors that have been out on the market now for a couple years, widely available from cloud providers and from OEMs, we're able to deliver amazing performance both in the cloud and on-prem. From an inferencing cost perspective, you can see here a couple of popular models, everything from DLRM for recommenders, BERT for natural language processing, Whisper for a more Gen AI type workload with translation, and then ResNet 50 for computer vision. You can see here a pretty significant lead in terms of the number of inferences per second per euro using the Ampere Ultra processor versus many of the other widely available solutions from NVIDIA, from Intel, and from AMD. And if you're looking to deploy on-prem or in your own data centers, you can see similar types of performance lead in terms of inferences per second at the server level when deploying our Ampere Ultra family processors. Plus, you can feel good about the fact that all of this performance is being delivered at considerably lower power than the alternative solutions. So let's look at a specific example. Now, NVIDIA talks a lot about using their DGX platforms for AI, and let's see what that might look like in a typical data center. So let's say a 1 megawatt data center with a 15 kilowatt limit per rack. If you deploy DGX servers, you'll be able to deploy one single DGX server with 8 H100s in that rack before you run out of power. You've left a lot of stranded space. You're not taking full advantage of your infrastructure. You probably needed to overhaul your data center, make changes in terms of power delivery, in terms of thermal capabilities, and as you can see here for an inferencing task, you're not getting any benefit from it. Alternatively, you could deploy Ampere Ultra family processors. You'd be able to deploy 40 servers per rack. You're not running out of rack power before you fill up the rack. In doing so, you can deploy 60 racks, 2,400 servers, as opposed to deploying 60 racks with 60 servers with the NVIDIA DGX platform. And the net benefit is you save about $7 million, and you're also able to deliver much more aggregate performance, 4.7 times more inferencing per second with the Ampere solution than with the NVIDIA solution. Plus, you have the added benefit that when you're running other workloads, as demand changes throughout the day, throughout the year, and you want to use that capacity for something else, you can run any workload on those Ampere Ultra servers. The NVIDIA DGX box, just a really inefficient space heater at that point. But we know that not many people are looking to spend $500,000 for one server, so let's look at a more practical use case. Now, same 1 megawatt data center. Now, maybe you're looking to refresh. You have a bunch of 6-year-old servers, pretty common out there today. What are your options? Well, you're not using the NVIDIA DGX box probably. You'd have to go and make a lot of changes to your infrastructure. So how can you maximize that infrastructure footprint most effectively? You could deploy AMD processors, either Milan or Genoa, or you could deploy Ampere Ultra Max. You can see here, Ampere Ultra provides the lowest cost and also provides the highest inferencing performance. So when it comes time to refresh, do so with CPUs and do so with Ampere CPUs. Now, to date, I've only talked about the Ampere Ultra family, 128-core processors. Last year, we announced our new product family as well, our 192-core Ampere 1 processors. These come with many, many improvements when it comes to AI performance, not only adding in additional features like bfloat 16, but you can see here significantly higher levels of performance and delivering even better efficiency. So you'll start to see more and more from the Ampere 1 side here as we proceed throughout the year, as more and more cloud providers and OEMs bring platforms out to the market. So at Ampere, we continue to deliver incremental products, delivering additional performance for workloads like AI, as well as increased efficiency. And when I look across Europe today, what's really impressive to me is the number of providers and the number of OEMs and ODMs that have made Ampere's technology available out to the market. Starting with Hetzner. Hetzner's probably our longest partner. They've been making both bare metal and virtual machine offerings available based on the Ampere processors. And we're really proud that they're also using Ampere processors in their US data center rollout as well. Schwartz and Stack IT. This is a newer customer, and they have Ampere processors being used for their compute engine, for their instance offerings. And what was really interesting about this one, to show you how easy it is to deploy Ampere processors, when we went and visited them the first time earlier this year, it turned out they'd already deployed our processors out in their infrastructure. It was that easy. So these guys just get it. They understand the need for cloud-native technologies across the entire stack, from the software layer all the way down to the hardware itself. Glesis. Glesis is using our CPUs for their really heavy compute workloads. And what's really cool about Glesis is the fact that the minimal amount of heat that's being put off by our chips is being recycled back into their hot water network that's being used locally. So you'll hear more from them throughout the year. Also, G-Core Labs. G-Core Labs has virtual machine instances available today. We're really excited about what they're building throughout the course of this year as well. And then last but not least, Scaleway. Scaleway is really focused on innovative technology, really being at the forefront of bringing new disruptive technology to the market, which is why we're very excited about what Scaleway's been offering. Back in the fall, they announced their virtual machine offerings and other offerings that are based on Ampere, and it's really only grown since then to also include AI. Now, instead of me talking about everything that Scaleway's doing, I wanted to invite up on stage Adrienne, the Chief Product Officer at Scaleway.
Hi, everyone. Hi, Jeff. Thanks for inviting me.
Yeah, absolutely. Thanks for being here today. Now, last November, you announced cloud instances that were based on Ampere. So what is Scaleway's strategy and commitment to scalable cloud, and how does Ampere fit into that strategy?
Right. So we're a full-stack European cloud provider. We're actually the first European cloud provider that rolled out servers with ARM processors back in 2014, so first generation. And so we launched at the beginning of this year our CUP ARM instances based on Ampere Ultra ARM chips. And so the goal for us is to offer alternative architectures So not just x86, but also ARM, and also to address all of our clients who are fans of that type of architecture and who are looking for cost-effective and more sustainable virtual machines.
That's really exciting. I know we share a lot of common interests in that space. Building out new technologies that can deliver better efficiency is good for all of us right here.
Absolutely.
Now, can you also talk a little bit about some of your current work on Kubernetes as a service with Ampere and beyond? How does that all map to sustainability as well?
Right. So basically, we're launching today our integrated Kubernetes with ARM offering. So the goal also here is for our clients to be able to build multi-arch images on both x86 and ARM, and to be able to basically scale sustainably with our ARM instances that are also hosted in our most sustainable data center. So scalability with sustainability.
And so we said a lot about sustainability and efficiency, and obviously Scaleway is really leading the charge in sustainability in the cloud, but also sustainability in AI. And what's really driving that? Why is AI part of that? What's next?
So yeah, sustainability is really part of our DNA, and so we've rolled out our supercomputer back in November. That's also based in our adiabatic data center. But the next step now is inference, as Jeff mentioned earlier. We're about to launch our first version of a managed inference product. We're starting with GPUs because we're addressing large language models. But the next step, we just did user research on the subject, and our users have told us that they're going to be using a mix of GPUs and CPUs, depending on the use cases. So if you're doing sentiment categorization, for example, you're going to use CPUs, and that's where basically our next step is going to be integrating inference on ARM chipsets, so we can offer basically a sustainable version of AI in production.
That's really cool, and it sounds like it's going to be easy for people to take advantage of this. And it sounds like you're seeing a lot of the same trends that we're seeing, where while training was the big focus a year ago, and still is important, there's more and more focus on how to build out that scalable inferencing and really taking advantage of multiple types of solutions, including CPUs in that type of build out. And
also the concern about the amount of electricity that's being used, and therefore how can we be more sustainable about our use of AI.
Absolutely, absolutely. Well, thank you, Adrienne. It was awesome having you up here.
Thanks,
really
everyone.
Excited. All right, well that's really, really cool. So as you can see, there's a lot more availability of Ampere processors, Ampere technology out in Europe and around the world today. We talked a little bit about the cloud providers that are making Ampere processors available to you, and there's plenty more if you're looking to deploy on-prem as well. I'm really excited about a couple of new GPU-free Ampere AI servers that are out there that are being promoted by a handful of some of our closest OXM partners. And you can see these platforms out in our booth today in E1. We have servers from Giga Computing, from HPE, and from Supermicro. So all of these servers are designed to be able to be utilized seamlessly with AI inferencing out of the box, take advantage of the performance and the efficiency savings with Ampere processors. So if you're looking to get started, I told you where the technology is available, where you can go and get access to servers and cloud instances. But you might be asking, what else? What other resources are available for me? What else should I be looking at? Well, we have a number of resources available at amperecomputing.com. Typically, our customers, you start to learn. You want to figure out what are the advantages. So go to our website. You can check out a bunch of our white papers around efficiency, around sustainability and AI. When it's time for you to start looking at a build-out, we have reference solutions available for you on our website as well. In the solutions site, we have solutions brief to utilize as you're building out, and then we have a number of optimization tools available for you, and a whole developer community where you can take part with other of your colleagues and share the amazing things that you're building on top of Ampere. And there are plenty of places to deploy, as I mentioned. So I want to thank everybody for being here today. And obviously, we are at a key inflection point here. As I said, energy consumption continues to rise. AI, while delivering amazing things, needs to be done in a sustainable way. So if you're looking to refresh your aging infrastructure that you're using for AI, go ahead and do that with Ampere CPUs. You saw the refresh benefits. There's no need to overhaul your entire data center, and there's no reason to waste the data center capacity that you have. So reclaim, repurpose your budget, your power, your space in using a more innovative solution, and overall reduce your carbon footprint to ensure that we can continue to grow AI compute over the next couple of years. So we're excited to have everyone here and excited to have you join us on the journey towards sustainable AI. Thank you.
Jeff, thank you so much for joining us.
Thank you.
I know you talked a lot about scalability, sustainability. Share with us a little bit more about like the average cost savings that you see for your customers.
Yeah, there's obviously very significant cost savings with a solution like this, and it comes from a couple of different places. One, you're getting a lot more performance within a given server or a given rack, so you have some upfront cost savings. There's also the savings from an operational perspective. It's less power to spend. You also don't need to invest in a lot of expensive technologies to overhaul your data center. So we've seen people save costs anywhere in the order of 2 to 5x, depending on kind of what the range of solutions they're comparing this to. So a very effective solution. And I should also just say, it's one that's also, because of the savings, it's then very easy to scale this out globally. So this, I think, is a large piece of how to democratize AI and make it available in all regions while being responsible about the cost and being responsible about the energy consumption in those regions.
Wonderful. Thank you so much.
All right, thank you.
Appreciate it.